Howdy, everyone. My name is Cora. I'm a senior biomedical sciences and entomology major here at Texas A&M. Today, I'm going to be discussing my research over honeybee nutrition, specifically macronutrient regulation, nurse bee nutritional preferences for protein and lipid. So, honeybees are the most effective pollinators on the planet, which is why my research is important. They account for a third of the food supply and contribute over $15 billion annually in the United States alone. So, they are crucial to the future of biodiversity and food security. But unfortunately, what we've seen in the last few decades is that honeybee populations around the world are declining. And in this figure from Bee Informed Partnership that showcases colony loss over time, we can see that the dark orange bars that represent total annual loss far surmounts what beekeepers believe to be acceptable, as seen by the light gray bars. And there are a few different reasons why researchers believe that honeybee populations are declining, and one of those reasons is habitat loss. So, with the growth of urbanization and large scale agricultural systems, honeybees aren't able to acquire the resources that they need from the environment to have proper nutrition. So, that lack of the quality, diversity, and quantity of pollen that they need for proper nutrition then increases their pathogen susceptibility and also decreases their survival and productivity rates. Now, pollen substitutes are a resource available to beekeepers during times of pollen dearth or when there's low quality pollen in the environment. And so there's commercially available substitutes like Bee Pro and Feed Bee that are fed to colonies with the intent to increase worker longevity and annual honey yields, essentially make up for what's lacking in the environment. But there is unfortunately not a pollen substitute that shares the nutritional value of pollen collected from the environment. That's because researchers don't yet know what pollen substitutes should be composed of to maximize honeybee nutrition and thus their health. Now, this is where my research comes in. We wanted to determine a macronutrient ratio of protein and lipid that would increase the survivorship of honeybees and positively affect their physiology. So to do this, we created 5 artificial diets that differed in their ratios of protein to lipid. So you can see we really created a range here in which we have protein-rich diets in the 35 to 15 and lipid-rich diets in the 15 to 35. So for all of our experiments, we used this cage design, and it's actually just a modified deli container in which we've placed wire over the top to allow for proper air circulation. We used a wax coating on the inside to give traction to bees so that they could reach these gravity feeders that we have sitting at the top of the cage. And the larger bottle is actually a sucrose water solution. And then we also have a smaller water only gravity feeder as well. So we first performed a no choice assay to study the functional significance of these diets. So are honeybees even going to eat these diets that we've created? So they did not have a choice in which diet they received. Each cage received 1 of 5 diets or a negative control in which they did not receive a diet at all. And we used this cage design for all of our experiments, like I said. And we also had these cohorts of 31-day-old bees within each cage. So we measured the daily consumption of bees by quantifying the amount of diet that remained in the cups, these little receptaca that we used to hold diets that you can kind of see at the very bottom of the cages. And then we lastly performed hypopharyngeal gland dissections, as these are a physiological indicator to the nutritional status of individual bees. So the first result we saw from our no choice assay was that the 30 protein to 20 lipid diet had the greatest amount of consumption. So in the figure on the left, we can see on the x-axis our treatment group in order of increasing protein content and the cumulative amount of food collected per bee on the y. And very clearly, you can see that the 30 protein to 20 lipid diet has the greatest amount of consumption. And now in the figure on the right, we're portraying the same information, but over time. So each of our trials lasted 6 days, and you can see that throughout the duration of the experiment that the 30 protein to 20 lipid diet had the greatest amount of consumption. Now, something interesting we also saw was that bees regulated their lipid intake to around 1.8 milligrams. And so in this figure, this is a geometric framework of the nutritional composition of bees. So you can see we have protein on the x-axis and lipid on the y. And each of our treatment groups, the different diets that we used, actually represent nutrient rails. So you can see that there's kind of a correlation around the 20-30, 25-25, 30-20 diets, and they all regulated their lipid intake to around 1.8 milligrams, even though none of these bees were in the same cages and they all received these different diets. So it suggests that there may be some lipid threshold that exists within honeybees and that they are regulating their lipid intake to around this mark we see here. Now, when we studied the hypopharyngeal glands, we saw that the 30 protein to 20 lipid diet had the largest gland size. This is important because these hypopharyngeal glands, the larger they are, the better nutritional status of bees. And that's because bees that have larger glands can increase their glandular secretions to feed brood. And so in this figure, we have our treatment groups in order of increasing protein content on the x-axis with the control as well. And remember, they did not receive a diet at all. And then we have our hypopharyngeal gland size on the y-axis. And this red line that you see running through the bars actually represents the protein consumption. And so you can see here that our 30 protein, 20 lipid diet had the largest hypopharyngeal gland size, and that there's actually a direct correlation with protein consumption and hypopharyngeal gland size. So we then performed a choice assay because now we want to see, do bees actually have nutritional preferences? What is it going to look like when we put two different diets in front of bees? And so we have these three treatment groups and with different diet pairings in each. And our treatment one kind of had a higher protein content. Treatment two is a bit of an intermediate group, and treatment three had a higher lipid content for them to choose from. And what we saw is that within each treatment group, the diet that had the highest amount of protein was consumed the most. And with their hypopharyngeal gland dissections, it was actually the intermediate group that had the largest hypopharyngeal glands. So again, whichever group had the largest gland size, this is saying those individual bees that we studied had the better nutritional status on a physiological standpoint. So this was one of the first experiments that actually manipulated protein and lipid content in artificial diets. And we mimicked our artificial diets after the composition of bee bread, which is a combination of nectar and honey and other carbohydrates that bees will use. And what we saw from these experiments was that bees had a preference for the 30 protein to 20 lipid diet, which was not the diet that had the greatest amount of protein, which differs significantly from what we see in commercially available pollen substitutes. And as you can see on this nutrition label of a pollen substitute that's really commonly used, there's a great amount of protein and an almost negligible amount of fat or lipid. And so our results suggest that we may need to rethink the composition of pollen substitutes if we want to maximize honeybee nutrition and help those declining populations around the world. Now, in the future, we hope to use these diets to study their effect on pathogen tolerance, specifically looking at deformed wing virus and nosema fungal spores, which are two very prevalent pathogens of honeybees and also a contributing factor to the decline in populations around the world. Now, I would like to thank my faculty advisor, Dr. Juliana Rangel, and my two graduate student mentors, Pierre and Alex, for teaching me everything that I know about bees and really just making this entire project possible. And then I would also like to thank our sources of funding for this project, the Louisiana Beekeepers Association and the Eastern Apiculture Society. So thank you guys so much for listening to my presentation, and I hope that you'll continue to save the bees. Thanks a gigum.